All right, we're continuing in our chapter on linear equations, and now we've moved into a section, literal equations and dimensional analysis. And so this is just a fancy way of describing where we're going to be looking at solving equations that have more than one variable, which is the definition, if you will, of a literal equation. And we're going to have to use our skills of one-step, multi-step, and distributive properties in order to be able to solve these for a given variable. So let's take a look at one. And this is the type of thing we'll see. You've got, I'm going to change, let's see, I want to change the color of this thing so it'll show up a little better. Let's go. We got an equation here that is 15 equals 3n plus 6p, and we're asked to solve for n. All right. Now, first I have to look at this, and we have three terms here. We've got a constant here in this one of 15. We have a term of 3n, and we have a term of 6p. And we're going to have to treat all these terms separately because in this equation they're separate terms. But we can still use our algebraic skill in order to solve these. So if I've got to solve for n, I can subtract 6p from both sides, and then that would give me 15 minus 6p equals 3n. Now, I can divide. I want to isolate this n because I'm asked to solve for n, and I can divide both sides of this equation by 3n. So we got 15 minus 6p over 3 equals n. And I can reduce this because 3 will go into 15 5 times, and 3 will go into negative 6p, or negative 6, 2 times. So then I've got 5 minus 2p equals n. And so here's an example here of solving for n a literal equation. So let's take a look at another one. Okay, this time we've got looking at, and I'm on page 126, by the way. I'm doing the guided practice problems in example 1 of 126 in your textbook. And so here we got k minus 2 over 5 equals 11j, and we're being asked to solve for k. Okay, so I got k minus 2 over 5 equals 11j. Well, I'm going to start here by multiplying both sides of this equation by 5 to get the 5 out of the denominator. And once I do, I'm going to have k minus 2 equals 55j. All right, so now I got k minus 2 equals 55j. Well, I don't have any coefficient other than 1 on this k, and so I can now just add 2 to both sides. So we got k equals 55j plus 2. All right, so there we go. We're solving for k, literal equation. We'll look at a couple more here just in a moment. Now let's look at a couple here where we're going to have to use some of our skill, our knowledge of distributive property that's going to allow us to solve literal equations. So here we're going to start here with 28 equals t times r plus 4 and we're going to be asked to solve for t. All right. Now, well, I'm looking at this, and I've got this 28. I need to be isolating the t. This is what I've got to isolate. But I've got this term here in these parentheses. And ordinarily, I might be thinking about I would distribute this t times r, well, that's tr, and t times 4 t. But that doesn't really get me anywhere where what I'm hoping to do. But since this r plus t is in parentheses, and I need to isolate the t, I can just simply divide both sides of this equation by what's inside this parentheses, r plus 4. So now I've got 28 over r plus 4 equals t. And I've done it. I've got the t isolated, 28 r plus 4, using aspects of distributive property in order to solve this. Now let's take a look at one more similar to that. And let's see, now we've got a little bit of a different wrinkle here, but we've got a times q minus 8 equals 23. Solve for q. All right, so now my q is inside the parentheses of this distributive property here. So I can't just simply, like I did in the last example, just divide 23 by q minus 8, because that's not allowing me to solve for q. But what I can do is I can start off by dividing both sides of this equation by 8, because this is really 8. This is really, divide both sides of the equation by a, because this is just a times q minus 8. So if I do that, then I'm going to be left with q minus 8 equals 23 over a. All right. Now, I don't have q isolated yet, but I can do so by adding 8 to both sides of the equation. And I would have q equals 23 over a plus 8. And what all this is leading us to is going to lead us to some working with formulas and doing what we call dimensional analysis, where we're not only concerned with variables and numbers or constants, but we're also going to be concerning ourselves with units of measurement, which is what we will become accustomed to, if you're not already, in your science classes and working with science and geometry and physics and chemistry and things like that. Okay, so I'm going to have one other slide here because I'm going to post something for you to solve yourselves. All right, so here's one for you. We've got Q equals P times R plus S, and what I want you to do is solve for P. All right, now, depending on where you're watching this at, if we're watching this in class, I want you to go ahead and solve for this. If you happen to be watching this as part of a homework assignment, which is possible, I want you to post the answer. If we're using Edmodo here, I want you to post the answer to this as part of watching this video for a homework assignment. Post the answer, solving for P, where you have an equation, Q equals P, parentheses, R plus S. So I'm going to give you a second to write that down before the slide ends. Okay, I'll be waiting for your answer.